Welcome to lesson 3.5. In this lesson, we're going to look at models, linear models specifically, and use slope-intercept form to create models for situations. So, we're going to be given 2 points, and using those 2 points, we need to make the model. First thing you want to do is use those 2 points to find the slope. So remember, slope is m equals y2 minus y1 over x2 minus x1. So let's do step 1. Okay, so after I plug those in, I get a slope of negative 1/5. So now I'm going to use that slope for step 2 and solve for b. So remember, our form is y equals mx plus b. I already know m, so I'm going to plug in negative 1/5 for m. And now I have 3 variables. So I'm going to use one of those points that were given to plug in for x and y. It doesn't matter which point you pick because they're both on the line. So they both should give you the same b y-intercept value. So I'm going to plug in a point, 15, 8. So x and y. So 8 is going to equal negative 1/5 of 15 plus b. So I can cancel 5 and 15. I get negative 3 plus b equals 8. Add 3 to both sides, and I find out that b equals 11. So my last step after I solve for m and b is to write it in slope-intercept form. So y is going to equal negative 1/5 x plus 11. And so now let's use those skills for a problem situation on minimum wage. So we know minimum wage, we have the law of getting to $15 per hour. So here's some scenarios, some actual data for Washington about minimum wage. So we're given dots, and the line or the model we're going to make should be a good fit. So that means it should kind of explain the trend that's happening. That means most of the dots should be on or near the line. So we want to be able to find an equation given 2 points. Now, to make sure we all get the same answer, the computer's going to tell us which points, but normally we can pick whichever. So I have 2005 and 2015, and we're only looking at after 2000, so that means we're going to use 5 and 15 as our y's. So we look back up at the table, and in 2005 it was $7.35, and 2015 we had $9.47 as the minimum wage. So I'm going to use those 2 points to solve for slope, and then use the same steps we talked about. And once you do your prediction, you'll find that the minimum wage wasn't really realistic. We can do that for height for boys based on age. So this middle line is the median, right? Middle, median. And given these data points on the graph, we want to be able to make a model based on the points for 3 and 15. So again, identify the points and do those steps. Find the slope, solve for b, write your form. So at age 3, the height was about 95 centimeters. At age 15, the height was about 170 centimeters. So then you're going to plug in and solve for m. So this is the expression I get. So to predict the height for a 10-year-old boy, I would plug in 10 for t. And my answer is pretty close to what I see on the graph. Now you're going to do that for the 16-year-old boy and the 30-year-old boy, or actually 30-year-old man as well. And you might not be as confident, or you might be the same confidence. And then you have to judge whether the 30-year-old man prediction makes sense. So I'm going to plug in 30 for T for number 11. Then we have to determine reasonable domain. So that's the side to side. Range is up and down, domain is side to side. So if we're looking at 9-year-old boy, they should be between 125 centimeters, maybe 124 and 144. So that's the height a 9-year-old boy on average is. And then if someone was lost and they measured the height, and we know they're 145, we can use this, the side to side, to figure out what age that boy is probably between. So it's probably between 9 and 13, since we're given whole numbers. So the key thing is